So, what probability is the chances of happening or occurrence of an event. Probability is what? The chances of happening or occurrence of an event. So, there is a random experiment. We have a sample space for that particular experiment. And probability of event E is what? Probability of event E is the number of favorable outcomes to the event E upon total number of possible outcomes. Got it? So probability of an event E is number of favorable outcomes to the event E upon total number of possible outcomes. So that is NE upon NS. Got it? So like if you throw a dice, what is the probability of getting an odd number? So there are three odd numbers, 1, 3, 5. Total number of outcomes are 6. It is 1, 2, 3, 4, 5, 6. So probability of event E is what? Favorable 3 upon total 6. That is 1 by 2. Got it? If the event E is the number turns up even or odd. So E is 1, 2, 3, 4, 5, 6. That is also S. So this is what? This is an example of sure event. Got it? This is an example of sure event. So probability of its occurrence is what? 1. Am I clear? Now, if the event E is number turns up is a multiple of 7. Now, how many multiples of 7 are there on a dice? No. There is no 7, there is no 14, there is no 21. The maximum number on a dice is 6. Means event outcomes in the favor of event is 0. Number of outcomes. So E is an empty event 5. So number of elements in E is 0. So probability of event E is 0. So this is what we call null event. If you remember yesterday I mentioned what is a null event and what is an sure event. So probability of occurrence of any event always lies between 0 to 1. Probability of occurrence of any event always lies between 0 to 1. Am I correct? Now, throwing a dice. Throwing a dice. Let it there is a set S having 1, 2, 3, 4, 5, 6. Got it? So, what is the probability that 1 appears is 1 by 6. Probability that 2 appears 1 by 6. 3 appears 1 by 6. 4 appears 1 by 6. And same for 5 and 6. And definitely there is no outcome beyond that. That means these W1, W2 and so on W6 are exhaustive events. They are mutually exclusive also because if one will come, it won't let two come. If two will come, it won't let any other number appear. So they are mutually exclusive, exhaustive and equally likely events. These events are equally likely, mutually exclusive and exhaustive. Got it? That is why sum of the probability of all of them goes 1. Sum of the probability of all of them is 1. Got it? Now, let's take a question. Which of the following cannot be a valid assignment of probabilities for outcome of sample space? S having W1, W2, W3, W4, W5, W6, W7. Now, assignment is what is a case. Chances of occurrence of W1 is 0.1, W2 0.01, W3 0.05, W4 0.03, 0.01, 0.2, 0.6. See, how do we judge if this assignment of probabilities is possible or not? How do we judge it? Yes, Mr. Rohit told it very correct. You have to add all of them. If their sum is going 1, that means that assignment of probabilities is correct. If their sum is not going 1, that means this assignment of probabilities is not correct. See, in case of B, it is very much clear. Everybody is having probability 1 by 7. So answer is 1. In C, if you see 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, this is going beyond 1. Their sum is going beyond 1. So this assignment of probability is not possible. Here if you see 0.6 plus 0.2, 0.8 plus 0.1, 0.9, 5, 3, 8, 1, 9, 10. This is also their sum is also 0.1. So sum of all of them is going 1. So that is also correct. Got it? Now, do a question. A die is thrown, find the probability of the event. A prime number will appear. What is the probability of getting a prime number? Quickly tell me. This is very simple. NCERT class 11th question it is. Then only I will be able to start the probability of class 12th. A dice is thrown, find the probability of following events. 2 by 6. Somebody told me, Madhukar told me, Rohit told 1 by 2. No, Rohit, there are only prime numbers. Sorry, Rohit is correct. See, there are how many prime numbers are there? 2, 3, 5. Got it? So probability that a prime number will appear will be 3 by 6. That is 1 by 2. Next, the number greater than or equal to 3 will appear. What is the answer? Quickly. More than or equal to 3 will appear. So probability favorable cases is what? 3, 4, 5, 6. Got it? So it is 4 by 6. That is 2 by 3. Number less than or equal to 1 will appear. Third part. There is only one possible case, that is 1. So answer will be 1 by 6. Very good. Number more than 6 will appear. On a dice, if you throw a dice, there cannot be a possibility that more than 6 will appear. So answer will be 0. Got it? Whoever is there from JNV rowing is answered very correct everything. Now another question. A card is selected from a pack of 52 cards. Then first question is how many points are there in the sample space? So elements in the sample space, they are called sample points. So first question is how many points are there in the sample space? Definitely we are aware of that. 52 cards means 52 points are there in the sample space. Second, calculate the probability that the card is an ace or a spade. So if you select a card, they are asking for the probability that the card is an ace of spade. So there is only one card, one ace of spade. Answer will be 1 by 52. Next one, that the card is an ace and second is a black card. So how many black aces are there? 2. One is of spade, one is of club. So the answer will be 2 by 52. Am I correct? 2 by 52. Yes, if they are ask them for separately, card is an ace, definitely it is 4 by 52. It is a black card, it is 26 by 52. But if the question is like it is a black ace, got it? It is a black ace, then there are 2 cards only. Answer will be 2 by 52. Am I correct? Now there is a question, see. There are 4 men and 6 women in a city council. If one council member is selected for a committee at random, how likely it is that it is a woman? Quickly tell me. There are 4 men, 6 women in the city council. If one council member is selected for a committee at random, how likely it is that it is a woman? How many women are there? 6. So means 6 women out of them divided by total 10 out of 1. So answer is 6 by 10. That is 3 by 5. Very simple. Clear? Now, see a question. A letter is chosen at random from the word assassination. Find the probability letter is a vowel or a consonant. A letter is chosen at random from the word assassination. Sivamani, Madhukar, Madhukar, am I audible to you? Can you switch on your mic for a moment? Madhukar. Hello, Madhukar. So, anyways, he is not interested in talking to me. So, a letter is chosen at random from the word assassination. If I list out the vowels A, I, A, I, O. These are the vowels and the consonants are S, N, T, N. So first question is it is a vowel. So 1, 2, 3, 4, 5, 6, 7, 8. Out of 13, there are 6 vowels. So answer for a vowel will be 6 by 13. And answer for a consonant will be 7 upon 13. Am I correct? And most of you have answered it correct. 7 by 13 is answer for 2, 6 by 13, 6 by 13. Very good. Easy question it was. Now, probabilities of event A or B and not A. See, you must have seen a formula. Number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. So this is what we call A or B. Got it? And what is not A? Not A is what? It is A complement. That is 1 minus number of elements in A. Got it? So probability of not A is 1 minus probability of occurrence of A. Am I clear? Now, so simply formulas that you have to remember. NA union B is NA plus NB minus NA intersection B. First formula. If A and B are disjoint sets, A and B are disjoint sets means there is nothing common in them, then A intersection B is going to be 5. So number of elements in A intersection B is going to be 0. So in that case, NA union B is NA plus NB. Got it? Number of elements in A complement is universal set minus number of elements in A. So if I divide it by NS, both sides, so probability of A union B will be PA plus PB minus PA intersection B. Similarly, PA union B will be PA plus PB if A and B are mutually exclusive events, which is what we call disjoint events. And probability of A complement is 1 minus probability of occurrence of A. Now see, fill in the blanks. Simple question, do it quickly. First case में PA 1 by 3, PB 1 by 5, PA intersection B 1 by 15. Then PA union B is PA plus PB minus PA intersection B. If you take LCM as 15, it is 5 plus 3 minus 1. So it will be 7 by 15, correct? So similarly, these other two questions you can do very easily. They're very simple questions. This is easy for you also. This is also easy. Okay, do this one. The probability that a student will pass the examination in both English and Hindi is 0.5, and the probability of passing neither is 0.1, means neither passing in Hindi nor passing in English. If the probability of passing in English examination is 0.75, what is the probability of passing the Hindi examination? Yes, quickly tell me. Yes, quickly, anybody? Sivamani? 0.71, Rohit is saying. Chalo. Let's do it. The probability that a student will pass the final examination in both English and Hindi is 0.5. So probability of E intersection H passing in both is 0.5. Probability passing in neither. Probability of neither in E nor in H is 0.1. So probability of E union H is 1 minus probability E complement intersection H complement. So 1 minus 0.1, it is 0.9. Got it? Probability of passing in English is 0.75 and probability of passing in Hindi they are asking. So probability E union H is equals to probability E plus probability H minus probability E intersection H. So PE union H is 0.9 minus PE 0.75 plus PE intersection is 0.5 is equals to PH. So PH came what? 1.4 minus 0.75. So it will be 40, 50, 65, 0.65. Somebody answered something. Rohit, did I make a mistake or you made a mistake? Rohit, okay, got it. Now this is where we start with the probability of class 12th. That is what we call conditional probability. So what is the conditional probability? So first of all, very simple thing is, I'll take an example. We express it like probability of A upon B. And we read it like probability of occurrence of A given event B has already occurred. So P A by B is probability of occurrence of A given event B has already occurred. Got it? This is what we call conditional probability. Like if you are throwing a dice, chances are getting 1, 2, 3, 4, 5, 6. Now somebody clearly mentioned that it is an even number. Am I clear? Now, what is the probability of getting 2? So if somebody has mentioned correctly that it is an even number, that means my sample space is not now 1, 2, 3, 4, 5, 6. Now the sample space is 2, 4, 6. Am I correct? So the sample space is 2, 4, 6. Out of that, what is the probability of getting 2? So probability of getting 2 is what? 1 by 3. Am I clear? So it is like if this is an event, this is a universal set where there it is A and this is B. So probability of A given B has been occurred. So B has already been occurred. So now this will be your sample space. That is what? Number of elements in B. And now along with this B, event A is occurring. So A is occurring here. In B, this is A. So that is number of elements in A intersection B. Now if you divide it by NS, that is the sample space, what do you get? Probability of A intersection B upon probability of B. Am I correct? So probability of A intersection B upon probability of occurrence of B. So this is what we call conditional probability. Like they have mentioned, in throwing a dice, what is the probability of getting 5? I know it is 1 by 6. Now in throwing a dice, what is the probability of getting 5 given that it is an odd number? So while it has been mentioned that it is an odd number, your sample space now shrinks to 135. Now out of that, you can say getting 5 is what? 1 by 3. Got it? Now say this is a chart of a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now what is the probability of Tuesday given that it is a weekday? Any random day you selected. Now somebody told you that it is a weekday, it's not a weekend. So if it is a weekday, what is the probability of it being Tuesday? So now it is 1 by 5. Got it? So P intersection P E upon F, yeah, P E by F is number of elements, elementary events which are favorable to A intersection F upon number of elementary events which are favorable to F. Got it? So PE by F is probability E intersection F upon PF. And PF upon E is probability E intersection F upon PE. Am I clear? So this is it. Now see a simple question. Given that E and F are events such that PE is 0.6, PF is 0.3, and PE intersection F is 0.2. What is probability of E upon F? So probability E upon F is what? Probability E intersection F upon PF. See, every time solving these questions, must write these formulas like PE intersection F upon PF. So if you write them, you will get familiar and used to them. So PE intersection F is 0.2 upon PF. PF is 0.3. So answer is 2 by 3. Similarly, PF upon E you can find. So F upon E will be PE intersection F upon PE. So this answer will be 1 by 3. Correct? Now, this is another question. PA is given to you as 0.8, PB is given to you as 0.5, and PB upon A is 0.4. Find PA intersection B, PA by B, and PA union B. So first of all, okay, you attempt it. Tell me the answer. Quickly do. Got it? See, PB upon A is given to you as 0.4. This is PB intersection A upon PA is 0.4. Now PA is what? 0.8. So PA intersection B will come as 0.4 into 0.8. So this is 0.32, correct? Now, first part answer is 0.32. Very good. Now PA by B. PA upon B is PA intersection B upon PB. You have both the values. So 0.32 upon PB is 0.5. So that will be 32 upon 50. So this is what? 0.64 it will come if you multiply divide by 2. Now PA union B. So PA union B will be probability of A plus probability of B minus probability A intersection B. So PA is 0.8 plus 0.5 minus PA intersection B is 0.32. Got it? So this will be 1.3 minus 0.32. So how much did it come? 130 minus 32, 0.98. Am I correct? Rohit, why are you getting everything wrong? 0.98 it will come. Now, next question. Mother, father and son line up at random for a family picture. E is the event that son is at one end and so many calculation mistakes are not good. Easy calculations are there. E is the event that son is at one end. F is the event that father in the middle. Determine E intersection F. See, E by F, probability E upon F. That is probability E intersection F upon probability of F. Now see, total ways of arrangement for them is 6. Yes or no? Now, event F is father in the middle. So if it is father, so son, mother and mother, son. There are 2 ways for them to get arranged. So denominator will be 2 by 6. Numerator is what? Son at one end and father in the middle. E upon F. If father will be there in the middle, then son will definitely be at one and probability will be 1. Yes. Now sun at one end is what? Again these two cases. Again 2 by 6. Answer will be 1. Got it? Now, this is easy question. Now multiplication theorem of probability. PE by F is what? PE intersection F upon PF. PF is non-zero. PF upon E is PE intersection F upon PE. PE is non-zero. Now F intersection E is E intersection F. So PF upon E is what? PE intersection F upon PE. So PE intersection F is what? PE into PF upon E. Got it? So this is what we call the multiplication theorem of probability or multiplication rule of probability. So PE intersection F is PF or PE by F, and P or PE into PF upon E. So EFG, if E, F and G are 3 events of sample space, if E, F, G are 3 events of sample space, then see PE intersection F intersection G can be what? PE, PF upon E into PG upon E intersection F. Got it? However, I require it. See, this will be the best way to understand. See a question. 2 cards are drawn at random and without replacement from a pack of 52 cards. Okay? Find the probability that both cards are black. See, what is the probability of drawing first black card? 1 by 2. Now you kept it aside. You did not replace it because it's a draw without replacement. Now in the remaining lot, there are 25 black cards out of total 51. Am I correct? Now you are drawing a card. Now what is the probability of drawing a black card? So out of 25, 1 will be drawn and total 51, 1 will be drawn. So your answer will be 25 upon 102. Answer will be 25 upon 102. Am I correct? Have a look. Madhukar got it? Got it? Now, see question. A box of oranges is inspected by examining 3 randomly selected orange without replacement. So you have drawn one orange, kept it aside. Now you have drawn another orange, kept it aside. Now you have drawn third orange. Got it? If all the 3 oranges are good, the box is approved for sale. Otherwise, it is rejected. Find the probability that the box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. Getting my point? That means this, even if one orange is not good, they will reject the box. Correct? So probability that box approved is 1 minus, the probability box is approved for sale is what? Not 1 minus. Keep probability getting a good orange probability getting a good orange before another good has already been drawn, and probability of getting a good orange before two good oranges have already been drawn. So first of probability of getting a good orange is what? 15 oranges, 12 are good. So it is 12 upon 15. Got it? Now, probability of drawing another good orange is what? 11 by 14. And then probability of drawing another good orange is what? Without replacement, it is going 10 by 30. So answer will be 12 by 15, 11 by 14 into 10 by 30. Now calculation, you can proceed on your own. Got it? Now, what are independent events? This is something very important. Independent events are like you have a coin in one hand, you toss that coin. All right. Now, you have a dice in another hand, you roll that dice. Does rolling the dice has anything to do with tossing that coin? No. Coin shows head, coin shows tail. It has nothing to do with what the dice will show. Am I clear? So that means if occurrence of one event does not affect the occurrence of the another event, or vice versa, means if two events are such that their occurrence is immaterialistic, if two events are such that their occurrence is immaterialistic, then their simultaneous occurrence, I should say, or is not getting affected by each other, then those events are what we call independent events. If you see on the exact definition, E and F are two events such that the probability of the occurrence of one of them is not affected by the occurrence of the other one. So such events are called independent events. So such events are called independent events. Got it? Now in general what happens? These independent events, they come from different experiment. Got it? In general, independent events come from different experiment. Different experiments is like, on the one hand, we are drawing a coin. We are rolling a coin. On the another hand, we are drawing a say card from a deck of 52 cards. So definitely they will be independent. But if they are from the same experiment, if two independent events are from the same experiment, in that case, there is a formula to judge if they are independent or not. Got it? Now you have a deck of 52 cards. You draw one card and then you slide it back. Then you draw another card. Then if you realize these two events became independent. So once you slide that card in the deck, now it is again a fresh deck. Now drawing a coin will be what? Independent from the drawing a card is independent from the card you have already drawn. So these events are independent. But yes, if you draw a card, you kept it aside and then you draw another card, then these two events are independent. Am I clear? So we have a definition. PE by F is PE intersection F upon PF. Yes or no? Now, if E and F are independent, then PE by F. That means what? Occurrence of E if F has already occurred. But since E and F are independent, E has nothing to do with F if it has occurred or it has not occurred. So this is equal to P. So definitely PE intersection F is what? PE into PF. Am I correct? So PE intersection F is PE into PF. Got it? So this is the formula for independent events. Two events are independent, then PE intersection F is what? PE or PF. And if this PE intersection F is not equal to PE into PF, that means events are not independent. Got it? Events are not independent. Now, there's a very thin line between independent events and mutually exclusive events. Mutually exclusive events are the events which or whose simultaneous occurrence is impossible. That means if event A and B are mutually exclusive and event A will occur, it won't let the event B occur. Got it? Means if you are throwing a dice, one will come, it won't let two come. So these events are not independent, they are mutually exclusive. Their simultaneous occurrence is impossible. But yes, if I talk about independent event, if one will occur, it should have nothing to do with if two is occurring or not. Getting my point? So these are what we call independent events, and they are completely different from mutually exclusive events. So in mutually exclusive events, probability of E intersection F is 0, and in independent events, probability of E intersection F is PE into PF. So if two events are such that they are mutually exclusive as well as independent, so if two events are such that they are mutually exclusive as well as independent, that means PE into PF is 0. So at least one of the two events has to be what? Impossible. Got it? Let's see a simple question. A die marked with 1, 2, 3 in red and 4, 5, 6 in green. It is tossed. Let A be the event that number appear is even. B is the event that a number appear is red. So are A and B independent? Okay. So probability of occurrence of E is what? Probability of occurrence of E. E number is even number. So even number, three even numbers are there. So it is half. Probability of occurrence of F. A be the event. This is not E, this is A. And B is what? Number is red. So red is what? Again 1 by 2. Now probability A intersection B. A intersection B is what? It is a even red number. So out of 3 red, 1, 2, 3, there is one even number 2. So A intersection B is having only one element 2. So it is 1 by 6. Am I clear? So definitely PA intersection B is not equal to PAPB. So events are what? Not independent. Got it? Now, do this simple question. A and B are independent events with PA as 0.3, PB as 0.4. Find these. Quickly do. Madhukar or Simamani, whatever you want to answer, open your mic and answer or write in the chat box. Yes, what is PA intersection B? If they are independent events, it is PA into PB. So PA intersection B will be 0.12, 0.3 into 0.4, it is 0.12. Got it? Simply PA union B will be what? PA plus PB minus PA intersection B. So PA plus PB is 0.7 minus 0.12, answer will be 0.58. Got it? PA upon B. PA upon B will be PA intersection B upon PB. So PA intersection B is 0.12 upon 0.4, 0.13, and PB by A will be PA intersection B upon PA. So 0.12 upon 0.3 is 0.4. Got it? So this is all from me for today. Practice more. है ना? Wait, Madhukar, practice more and get through. This is an important chapter in boards as well as in J. Now I would like to ask for a small feedback. Yes, please.